You can do some very cool stuff with template matching in OpenCV, and in this video, I'm going to show you one possible usage that I think could make a pretty cool app. So let's dig in. Hi, my name is Chris, and welcome back to my OpenCV in C# series. This series is meant to introduce and give you all the tools you need to use OpenCV to its fullest extent, as well as some foundational building blocks on your computer vision journey. In this video, as mentioned, we're going to talk about template matching. So, what is template matching? Well, it's a way to find the location of a smaller image inside of a larger image. You have your smaller template, then that template is applied to the image, sliding it over each pixel, and seeing how similar the two slices are to each other. You could theoretically use this to find, say, a ring from Sonic, on the actual video game screen. So if you had a smaller template that was a picture of that ring from Sonic, you took that smaller template and you had an image of, the game screen in Sonic, you could then use template matching to identify the rings on the screen, right? So that's essentially what template matching is. You can do it for pretty much any type of object or template, because the system does not care what you're looking for or anything. It's, here's my little template image that is just this matrix of pixels, and I need to find a similar matrix of pixels in this larger image. So it really is as simple as that. It's not extremely sophisticated, so there's a lot of limitations to it, but for our purposes, it's actually going to do something very cool, and let's get into that with starting the example. I teased it a little bit in the intro to the video, but basically the little example I'm going to show you here is an idea I had for an app a long time ago that I never ended up building, but I think it's definitely at the time was a very interesting idea. Basically what it is you have a multiple choice test, picture. So someone who filled in a multiple choice test, and then you take templates of the possible answers, for instance. So let's say all possible answers of A, all possible answers of B, whatever. And you identify on the test that the student took what they answered through template matching. You could use this theoretically to just have an automated Scantron type system, but with just a phone app, for instance. So we'll show that, but that's the kind of example I want to go, because I think that's a decent example of usage of template matching, because like I said, it's kind of limited in what it can do. There's some cool stuff you can do for sure, and so I did want to actually show it in the series, but there's more advanced ways to do this kind of stuff, but I'm just going to show you this. So the project, the example we're going to build, it requires two images, and I'm going to move those into here. So our two images are our answered test. So I just made this. One day, and actually you can tell this is originally from my app idea, because I put QR codes in here for orientation. And then also we have a template. So let's say we're going to search for anywhere that the user would have answered A, right? So we can go in here and, oh, that one's like, they answered A, but it's not perfect. So will template matching work there? We'll find out. But it's just going to go through and find everywhere where it answered A. So that's the example idea. Let's get started on that. All right, so let's get started in our example. The first thing we're going to do is we're going to import Emgu, as always. CV, and we'll also need Emgu.cv.structure. Okay, and then we are going to create some mats. That's just what I name these. This should be img grader page answer.jpg. I could have named that shorter for ease of typing, but here we are. And then our template. Speaking of interesting names to type. All right. Okay, so we have our mats. Okay, so just to talk about this real fast, template matching the size of your objects matter a lot. So if you rescale one of these objects, the template will no longer probably be found in the image unless you're looking for something very generic. So if you do rescale stuff, you should do it to both the template and the original, and you should do it at the same ratio. So actually, let's do that. Let's try a resize. And this, we may end up not liking this, but that's okay. That's just part of what's going on here. So I do want to show you a new thing that I don't think I've showed before. For resize, if you give it 0, 0 as the size, and then you see there's two more parameters here after the size that's called double fx and double fy. These are basically scaling factors. So let's say we wanted to reduce our image by 30%. So we could give it a scaling factor of 0.7, and from there it knows, because we gave it a size of 0, 0, it knows that, okay, we're going to use these scaling factors, so we'll do the width by 0.7, we'll do the height by 0.7. Okay. And then from there, we're going to do the same thing to our this. Okay. Yeah, and like I said, making sure that we have the same ratio going both ways. All right, so then from here, we need one more mat. We need a template output mat, and I'll show what that is in a moment. And then we're going to call the start of our show. It's called MatchTemplate. It's another CvInvoke function, and it has some arguments here. Our input is going to be our answered pick. Our template is going to be our A was answered, and then our result is going to be in template output. And then it takes another argument that is, let me bring that back, that is a template matching type of method. And this is important because depending on which ones you pick, it actually impacts how you use the data later on. So in our case, we're going to use one called Emgu.cv.cvInvoke.TemplateMatchingType. And here's the options. So if you pick one of these two squared differentials, template matching types, this actually changes the outputs to where I believe you're looking for a min value from your output instead of a max value. And then if you use the coefficient ones, or these others, you're going to need the max value is going to be your found image. So we're going to use the COEFF normed one. And you can see what it does there. That's the actual math behind the matching. So, you can look further into that if you wish. It's, I don't really necessarily need to go through the explanation here. You can look at the documentation and see the differences. Some of them work better than others. And that's something that you do probably want to understand a little bit when you get into template matching, because it changes, depending on what you're trying to do, it could affect things. So just know that. All right, so from here, we're gonna make a double min val, and this is going to be our min and max values in the template that comes out. And there's two other things that come out of this. There is a min location and a max location, and those are system drawing.points. And then copy and paste that, and it's going to be max loc. Technically, we're not really going to use these, but I wanted to show that. I wanted to show another function that will give you some data from your template. And actually, right now that I think about it, let's actually just go ahead and show that template. Because I want you to see what kind of data you get out of it. Oh, I need to name it. Okay. And then we'll go ahead and do our wait key. Okay. So let's execute this. Let me double check. I am okay. All right. So I'm in main. Let me execute this and we'll see what we get. Oh, I mistyped. I mistyped the name. It is ABCD. I wrote DC. Sorry about that. All right, let's try this again. We'll kill it, run it. Okay, this is our output. So we have some data in the image that is, for instance, the black ink. They picked up in our template. And the reason for that is the template itself has that in it. So anywhere where you see stuff like that, it's going to, to varying degrees, match, right? You know, the QR code obviously doesn't look like our template, but it kind of matched in there. So I just wanted to show this real quick, and we will look further at this in a moment. So that gives us our template output. Let me delete that. And now let's look at the actual values you're going to get out of this kind of stuff. So we're going to do a CvInvoke function called min max loc. Finds the minimum and maximum element values and their positions. Okay. So we're going to do that in template output. And we're going to pass min val, max val, min loc, and max loc by reference. If you don't know what that means, basically, we're going to instead of passing the value of these, which these are value types, these two are. So by default, you would pass a value, and anything you did to that value in the function would not update the original value, right? But the way they wrote this this static class here is they just want you to pass a reference to that value, means a pointer. And so anything they do in this function to that pointer, to that variable, it's going to actually update it back where you have it. So we're passing a reference to min val, and that means anything done in here is going to actually update min val, which is a little different than you might be used to. So we're going to pass min val, max val. We're going to pass a reference to min loc, and we're going to pass a reference to max loc. Okay. And then that's going to basically take our template output, store the minimum value, the maximum value, the minimum location, and the maximum location. And I just wanted to show this function. We don't technically need it, but I wanted to show this function because these values here, you're going to be able to do some good stuff with those. So that's important to see. Next, we're going to do our threshold function. And basically what this is going to do is it's going to filter out, you remember all the noise we saw in our template, it's going to filter out anything that doesn't meet a specific threshold. So we're going to do that template output, and we're going to store the output of threshold back into template output. And then it's asking for this threshold value. This is something that you're just going to have to play with to determine. In my case, I used 0.85, and that gave me a pretty good result. So I'm going to do that. But that's a parameter that you would tweak. Max value, we'll just do 1. And then again, or sorry, not again, but we have a threshold type. So the threshold type we're going to use, and again, these are things you can play with. I'm going to use one called 2.0. They all do different things. And again, I don't necessarily want to go into every single one of them, but just know that can impact some of this too. So, but we're going to use 2.0 for now to get the effect we want. Okay, so now we've filtered out anything that doesn't match basically a 0.58 or 0.85 intensity on the original template. So basically this matrix of our matches to our template we filtered out everything that wasn't a great match, and we've only got things that are good matches left. Okay, cool. So why don't we just go ahead and show that real quick. I want you to see what that looks like. Okay, and then we'll run this. Oh, I have the old one open. All right. Okay, so you'll see we filtered out all the other stuff, and what we're left with are these little dots. And these little dots are the starting locations of where our template matched the best. And if you remember what our image looked like, I can pull it up here. You see that it matched, it pretty much picked up exactly where we answered A. So we matched our template. Very cool. Okay, hopefully that all makes sense. So now we've got our data for where the template matched in the picture itself, and we've filtered out all the bad matches. So now we've only got good matches. So question is, what do we do with it? And depending on the type of app you're building or the type of, whatever, that can change. In our case, I'm actually just going to show you how to draw rectangles over where the template matched, just to kind of show you visually where we found it. If you were, for instance, if this were a real application, a real app to grade a student's test, what you might do is you might take that information, you might match it to a positional template match of the numbers, for instance, of each question. And then you may say, well, this student answered A for number 1. Turns out 1 was actually C, so count that one wrong, in the program itself. So you've got the data, now you just need to do something with it. And again, in our case, I'm just going to draw some shapes on top of it to show you visually. So I'm going to show you how to do that real quick. We're going to create a new var called matches. And just double checking in case you're new to C#, var is an implicit type. It basically just means you figure it out to the compiler. And we're going to, and save us some typing here, and we're going to do toImage and gray byte. And so what this is saying is we're going to take our template that we now have our good data in, we're going to create an image of types gray byte. And so basically we're putting our grayscale image in here. We specifically have this image object. And the reason we're doing that is because it's easy to iterate over. So we're going to iterate through matches, which is our image of our threshold image. And we're going to iterate through it and finding the places where it matches the intensity we want. So if you remember how to iterate through an image like this is we're going to do .rows. So we're just going to do, typical double for loop to iterate through this kind of two-dimensional array. Just as an example. Okay, and then the thing we're going to do, we're going to be looking for if matches sub ij dot intensity is greater than some value, let's say 0.8, and I believe this is a direct correlation to this. So we only should have values that are over 0.85. So 0.8 is fine. You could also just say 0.4, and I don't know if this is inclusive or exclusive. So just to be safe, you could do that. But just for right now, we'll just 0.8 and that should work perfectly fine. So if that pixel we're in, the intensity of that pixel matches or is greater than 0.8, we want to do the following. So we're going to have a system.drawing.point, and this is going to be our location. We'll just call it loc. Drawing.point, and we're going to do this point at ji. So that's the first thing this is our location of where we're currently at. And then we're going to do a system.drawing.rectangle box, and we're going to do a new system drawing rectangle, and the arguments for rectangle are going to be a point, which is loc, and size. And so the size we're going to use is actually our template size. So if you remember, our template was in the mat A was answered, and we can do .size for that map. So now this rectangle is going to be at location loc, and it's going to be size of our template. And remember, loc is our current location in the image as we're iterating through it. Okay. And then from there, there's a CvInvoke function called rectangle. And we're going to draw our rectangle on our original picture that we're looking at. And we're going to draw a box. That's the rectangle we're using. And we're going to give it a color. And the way they're doing color in here is with an MCV scalar object. So we're going to do a new Emgu.cv.structure. MCV scalar. And we're going to make them green. You can do whatever color you want. And then the next is a thickness of the rectangle. So in our case, we're going to do a 2 just to make it a little easier to see. You can do whatever thickness you want there. Really funny to do like 1,000,000 and it just covers the whole thing. All right. So yeah, that's the code. Now we just need to show this so I can actually show you what that looks like. Oop. So I'm just going to do an invoke.show. On our answered pick, which again now has the triangle, or I keep saying triangles, the rectangles drawn on it. And then invoke.show. I'm also going to show the original template so you can see the kind of correlation. Or not the original template, sorry, the threshold matrix of where our template was detected. Okay. I believe I got rid of, yeah. Okay. All right. So let me run this. All right. And so you see, it actually found, I believe, every instance of where A was answered. So if you think about it, how does it know that this is A, but this is not? And really what it is our template has a B shape here, a C shape here, a D shape here, which does not match the F, G, or H shape. Though I will say it does match it. It's just a lower threshold than what we filtered out. So the threshold that we use to create this is pretty important. And depending on what you're doing, matters if you find a match or not. If our threshold was 0.6, for instance, all of these would be filled in as well. Anywhere they answered E would be filled in here or here, etc. But because we set our threshold correctly, we're getting correct answers of A, and even matched this one, which honestly I was not sure if it would or not, but it actually does. So that's pretty good. That's better than a Scantron probably does. So. All right, so in this video, I gave you another OpenCV functionality use case that I bet you could come up with some cool apps with. If you want more OpenCV tutorials or just more programming content in general, let me know in the comments about what you'd like to see, because I'm open for suggestions. I'm kind of just doing things I'm interested in, but if I get enough interest in something else, I'm totally down to do that. And kind of speaking of, if you want more programming content, if you haven't seen it yet, you may want to check out my Dev Level Up series, where I create little bite-sized chunks of information to kind of fill in some gaps that devs might miss along their learning journey, especially if they're early on. If you're early on learning C#, you probably didn't dig into that stuff, at least the ones I've made so far. So I would highly recommend clicking that and taking a look at those. They're really quick. You can get through them really fast and hopefully learn something. So if that sounds good to you, click right here. Otherwise, I will see you on the next one. Thanks. Bye.